If you've spent even a little time in school during the last few decades, the following scenario will likely be very familiar to you. You need to prepare for a test, so you commit to sitting down for a few hours with your books. You go over the material again and again, trying to drill the facts into your head so that you can recall them later. Maybe you read written sections over and over, or try rewriting or reciting the material out loud, as though you were a sponge trying to absorb as much as possible. At the end of the preparation phase, there's more highlighted in your notes than not, and your memory retention is questionable. You do feel pretty good about yourself, though, and you even pulled an all-nighter trying to cram the information into your noggin. People will be suitably impressed with you. The rest of the scenario is also probably familiar, i.e., the part where you walk into the exam room and can only recall a small part of what you learned anyway. And yet, you probably also know someone who excelled at school and just seemed to have a knack for remembering everything, absorbing it all with ease, and having it stay in there well after the exam came and went. They may have even done this with fewer hours spent studying. While you were inside highlighting the same passages with red, yellow, and green, they were outside riding their bike or engaging in a hot dog eating competition. Why? How? That's not fair. This book tries to answer those questions and look not just more closely at the methods for learning and memorization we've all been taught, but a little deeper at the neuroscience behind how your brain takes in, organizes, and holds on to new information that you give it. The truth is that we can optimize abstract functions like memory, recall, and information processing by looking at the very concrete physiological basis they have in the brain itself. Armed with this knowledge, we can work with our brains to their greatest potential, in much the same way as an understanding of anatomy and biology helps an athlete perform at their physical peak. You may have underperformed academically, or can't seem to keep it together for your job, but that's entirely changeable. You've probably felt the limits of your own cognitive capacity at times before, and desperately tried to push past them. But rather than doubling down on the same old tactics we've been taught at school, this book tries to understand the brain's natural capacities in order to work with them. A brain that's better able to take in information, process and analyze it, and recall it is always going to be an effective, powerful brain. And it's hard to overstate the value of such an asset, whether that's at school, at university, in your career, or in life in general. In 1953, Henry Molaison lost his mind. Well, part of it anyway. You might recognize Henry from his more anonymous yet infamous moniker of Patient HM. In a desperate attempt to stop steadily worsening seizures, Henry's doctors decided to carefully remove 2 thumb-sized pieces from either side of his brain in an experimental procedure. Though the seizures did indeed stop, Henry was left with a permanent type of amnesia. New memories were impossible for him to form. He could meet a new person, and if they left the room and re-entered, he would behave as if it were the first time he'd ever seen them. Henry Molaison's long-term memory wasn't affected, and he kept his personality and skills intact, even learning rudimentary new skills in the moment, most motor skill-based. He just never had the memory of having learned them. What was a tragic outcome for Henry Molaison was an interesting new beginning in neuroscience. Here was proof that the function of memory was explicitly tied to discrete physiological areas of the brain. A handful of other patients underwent the same procedure, and in each case, the doctors discovered that memory was always affected when portions of the medial temporal lobe were removed. The more of this tissue that was removed, the more extensive the impairment to the patient's memory. This was a turning point in understanding the function of the brain, and it's integral to our understanding of NeuroLearning.